confidence intervals and hypothesis tests for a proportion. The most common confidence interval for a proportion is the walled interval. It takes the form p hat plus or minus z star times the standard error. The three building blocks are the point estimate p hat, the critical value from the standard normal distribution, and the estimated standard error, which uses p hat and q hat in place of the unknown p and q. Let's visualize this for our smoking example. With p hat of 0.298, a sample of 57, and a 95% confidence level, the margin of error is about 0.119. The confidence interval stretches from about 0.179 to 0.417. We are 95% confident the true smoking prevalence lies in this range. One important caveat: the walled interval can perform poorly when the sample size is small or p is near 0 or 1. In those cases, the Wilson or +4 interval is preferred. Now let's test whether a population proportion equals a hypothesized value. We set up the null hypothesis, p equals p naught, against the alternative that p does not equal p naught. The test statistic is z-stat equal to p hat minus p naught divided by the standard error. Notice that we use p naught, the hypothesized value, in the denominator. This is because under the null hypothesis, we assume the true proportion is p naught. Let's apply this to our smoking example. We have 57 adults, p hat is 0.2982, and the national average is 0.25. Computing z-stat, 0.2982 minus 0.25 divided by the square root of 0.25 times 0.75 over 57. That gives us z equals 0.84. On the standard normal curve, the shaded red regions show the rejection zones at alpha equals 0.05. Our z-stat of 0.84 falls well within the non-rejection region. The two-sided p-value is 0.401, which is large. We have weak evidence against the null. The sample proportion is not significantly different from the national average. Before collecting data, how large a sample do we need? The required sample size is z squared times p hat q hat divided by m squared, where m is the desired margin of error. If we have no prior estimate of p, we use the conservative approach and set p hat to 0.5. This maximizes the product pq and gives the largest required sample size, simplifying the formula to z squared over 4m squared. To sum up, the walled confidence interval for a proportion is p hat plus or minus z star times the standard error. For small samples, prefer the Wilson or +4 method. The z-test lets us compare a sample proportion to a hypothesized value, and we can determine the required sample size before data collection using the sample size formula.